Great Day Mathematics. Today we proceed to the 2023 University of Florida Integration B qualifying round part 2, where we'll be looking at problem 11, problem 12, problem 13, problem 14, 15, 16, 17, 18, 19, and 20. So these are very interesting problems. We'll spend some time dissecting them and solving them, and hopefully somebody might be able to benefit from it. But what we do here at Everyday Mathematics is we do love mathematics. We go about on a run and look for any problem that may seem interesting, and we solve them and we share with you. So without much ado, if you haven't subscribed to our channel, I'd like to encourage you to subscribe to our channel, because here at Everyday Mathematics we do interesting problems, and we hope that your support might go a long way in increasing our profile and helping us reach broader audiences. So yeah, without much ado, let's move forward to the solution phase of this problems. In number 11, which is limit as capital R tends to infinity of the definite integral from x equals to capital R to x equals to capital R plus 1 of 1 plus x over x. So this problem could be rewritten as that, and we have 1 over x plus x over x. You see that that becomes one over x plus 1, and so this becomes, now this guy here integrated is the same as natural logarithm of x plus x r to r plus 1, which is equals to limit r tends to infinity of this part becomes natural logarithm of r plus 1 plus r plus 1 minus natural logarithm of r plus r. So you can see that this and that goes, and then this and that we can re-express as natural logarithm of r plus 1 over r plus 1. So if we divide both the numerator and the denominator by r, we have 1 plus 1 over r over 1 plus 1. And so as r tends to infinity, we get this part going to 0, and so this becomes natural logarithm of 1 plus 1, and since this tends to 0, we are left with 1 as the answer. And so our problem now becomes limit as r tends to infinity of the integral from x equals to capital R to x equals to R plus 1 of 1 plus x over x equals to 1. And that, ladies and gentlemen, is our answer. Okay, so we'll now move forward to problem number 12. So on to problem number 12, which is the definite integral from x equals to 0 to x equals to pi of 4x sine x over tangent of x. So how do we solve this problem? My first instinct is to look at this secondary trigonometrical function and try to express it in the primary functions of sine x and cosine x. So which will be 0 to pi of 4x sine of x over sine of x over cosine of x. As you can see, this and that cancel, so our problem now becomes 0 to pi 4x cosine of x. Now, this can also be written as 0 to pi. Let me pull the 4 out. So we have x times the derivative of sine of x. So cosine of x is the same as the derivative of sine of x. And here I'll create a small rectangle to remind us of that beautiful formula that tells us about integration by parts. So if the integral of the function v times the derivative of a function capital U, when you integrate that, you have u times v minus the product of the function u times the derivative of the function v. And so in this instance here, we have that as our u, since we have the derivative of sine of x, and then this would be our v. So in other words, our uv is 4x sine of x from 0 to pi minus 4. Now we'll have to write sine x here, but the derivative of x will follow. So here we get 4 pi sine of pi minus 4 0 sine of 0 minus 4 sine of x. There's 0 pi here, 0 pi here. So interestingly, as we see here, sine of pi goes to 0. This goes to 0, this goes to 0. So everything just boils down to negative 4, 0 to pi, sine of x. Now, negative sine x is the same as the derivative of cosine of x. So in other words, we have 4 cosine of x, 0 to pi. Okay. And so what we do have here now is 4 cosine of pi minus cosine of 0, which is 4 negative 1 minus 1. And this is equals to 4 times negative 2, which is negative 8. So what we are seeing here is that the integral from 0 to pi of 4x sine of x tangent of x is equals to negative 8. Okay, so that is the answer. So next we go to problem number 13. Problem number 13, which says that we do have a definite integral from x equals to negative pi over 2 to x equals to 2023 of sine of the absolute value of x minus x. So what is the absolute value of x? Absolute value of x is equals to negative x when x is negative, or when x is less than 0. It's 0 when x equals to 0. It is x when x is greater than 0. Therefore, what this integral that we have leads us to can separate this into two separate integrals. So we have from negative pi over 2 to 0 of sine of negative x minus x, plus from 0 to 2023 of sine of x minus x. And this obviously goes to 0, so this entire enterprise goes to 0. So our main focus is this definite integral from x equals to negative pi over 2 to 0 of sine of negative 2x, which is the same as this negatives propagates out, and so we have negative, the integral from x equals to negative pi over 2 to 0 of sine of 2x. And so this negative here means that we have a half cosine of 2x negative pi over 2 to 0. So which becomes a half cosine of 0 minus a half cosine of negative pi. So first of all, cosine of a negative is a positive cosine. So what we have here is a half minus a half negative 1. Cosine of pi is negative 1. So this becomes positive 1 as our answer. Okay. So on to problem number 14. Problem number 14, which is the definite integral from x equals to 0 to x equals to pi, the square root of x plus the fourth root of x plus the square root of pi squared minus x squared. So this is an easy problem. I may just first of all rewrite the problem to the integral from 0 to pi of x to the power a half plus x to the power quarter plus the square root of pi squared minus x squared. Now this may be a little bit interesting, but I think plotting it out might help us. So we have 0 to pi. At 0 we have this being pi. At x equals to pi it becomes 0, so we do have a quadrant here. And so what happens is we can now integrate this as obviously adding 1, this becomes 3 over 2, so we do have 2 over 3 x 3 over 2 0 to pi plus, and then this becomes 4 over 5 x to the power 5 over 4 0 pi, and the area of this quadrant is a quarter times the area of the circle would be pi. Since the radius is pi, we have pi squared. So this becomes 2 over 3 pi to the power 3 over 2 plus 4 over 5 pi to the power 5 over 4 plus a quarter pi cubed. So that's the much we have for this problem, and I think we can just underline it like that. It's a very simple problem. So let's continue to the next problem number 15. Problem number 15, which is the indefinite integral of log to the base 3 of 9x. So we want to do some few things. So if we have log to the base of a of b, that's the same as log to the base of c of b over log to the base of c a. So this is a well-known relationship. And so here we would like to re-express this in terms of the natural logarithm. So we have, well, the natural logarithm of 9x over the natural logarithm of 3. So I think that's a big fast start. And so the next thing I want to do is there's a hidden 1 there, so we can say this is the same as the derivative of x times the natural logarithm of x, or 9x rather. And then using integration by parts, and what does integration by parts tell us is that if we have an integral of two functions, one v and next the derivative of function u, then when you integrate that you have u v minus u dv. And so if we take x to be our u and v to be natural logarithm of 9x, then we have 1 over natural logarithm of 3 x natural logarithm of 9x minus 1 over natural logarithm of 3 integral of x, the derivative of natural logarithm of 9x is 9 over 9x. And so the 9's cancel, and then the x also cancel. So we have 1 over natural logarithm of 3 x natural logarithm of 9x minus 1 over natural logarithm of 3 times the integral of 1. So this becomes 1 over natural logarithm of 3 times x natural logarithm of 9x minus 1 over natural logarithm of 3 x plus c, the integration constant. And that, ladies and gentlemen, is our answer. So on to problem number 16. Number 16, which is a definite integral from x equals to 0 to x equals to infinity, or x tends to infinity, of x to the power negative half times e to the power negative x over 2. Now, I think one may want to begin by saying let x be let square root of x be equal to u. Rather, u squared be equal to x, and therefore 2u du dx equals to 1. And therefore, what happens here is that 2u du can be used to substitute for dx. And so when x equals to 0, u would be equal to 0, and x tends to infinity, u would also tend to infinity. So this becomes 0 to infinity of 1 over times e from here negative u squared over 2 dx is the same as 2u du. So that cancels. So we come to 2, 0, infinity, e to the power negative u squared over 2. I think one other substitution would be apt. We could say let y be equal to u over square root of 2, and that means dy du is equals to 1 over square root of 2, and therefore square root of 2 dy can be used to substitute for du. And then the limits would remain the same, so the problem now becomes twice 0 to infinity of e to the power y squared square root of 2 dy. And this becomes 2 root 2 square root 0 e negative y squared dy. So our problem has come to a point where we have 2 root 2 0 infinity e to the power y squared dy, and this here is half the Gaussian integral, so it is root pi over 2, and so this becomes root 2 pi. So in other words, our original problem, integral from x equals to 0 to infinity of x to the power negative a half e to the power negative x over 2 is equal to 2 root 2 pi square root. And that is our answer. So moving forward to problem number 17. So next, our problem is the definite integral from x equals 0 to x equals to pi of the summation from n equals to 0 to n tend to infinity of 2023 over n factorial cosecant to the n of x times secant of x. So the first thing is all these secondary trigonometrical function. So one thing I could do is, first of all, I could bring this out, since the integration of a summation of items is the same as summation of integration of specific items. So this is the same as summation from n equals to 0 to infinity of 1 over n factorial, then integral from 0 to pi of 2023 over cosecant of n of x sec. And so we could still even pull this constant out. So summation from n equals to 0 to infinity of 2023 over n factorial 0 to pi 1 over, we have 1 over sine to the n of x, 1 over cosine of x. So this is same as n equals to 0, 2023 for n factorial times 0 to pi of sine of x times cosine of x. Now this here is the same as the derivative of sine of x, and what that means is that our problem is the same as the summation from n equals 0 to infinity 2023 over n factorial integral 0 to pi times the derivative of 1 over n plus 1 sine of n plus 1 of x. Okay, so this becomes 0 to infinity 2023 over n factorial, and we have 1 over n plus 1 sine of to the n plus 1 of x 0 to pi. And we can see that the sine of pi to the power n plus 1, a sine of 0, so this entire thing goes to 0. And therefore what happens is that we have 0 as our answer. So what we're telling ourselves here is that the integral from 0 to pi, the summation from n equals to 0 to infinity of 2023 over n factorial times cosecant to the n of x times sec to the power of x, this is equal to 0. Okay, so moving forward to problem number 18. So problem number 18 talks about integrating a definitely from x equals to 4 to x equals to 8 of the square root of x to the power 4 over 256 plus x to the power 3 over 32 plus 5x squared over 16 plus x plus 4 plus 16x minus 8 times square root of 4x minus 7 minus 24 plus twice the product of x squared over 16 plus x over 4 plus 2 and minus 2 plus x times 2 times the square root of 4x minus 7. So what is easy to see is what we have here is if we have a plus b squared, that's equals to a squared plus b squared plus 2ab. And a squared plus b squared is what we see here. And 2ab is what we see here. So in other words, this is the same as the integral from x equals to 4 to x equals to 8 of the square root of x squared over 16 plus x over 4 plus 2 minus 2 plus 2 square root of 4x minus 7 all squared. So this and that cancel, so we have 4, and since these two go, we have a square root from x equals to 4 to x equals to 8 of x squared over 16 plus x over 4 plus 2 times the square root of 4x minus 7. So what does that tell us? What it tells us is that we can integrate this individually, and so we have x to the power 3 over 3 times 16 plus x squared over 2 times 4, which is 8, and all these 4 to 8 plus twice integral from x equals to 4 to 8 of the square root of 4x minus 7. So this is the same as 8 cube 316 minus 4 cube 316 plus 8 squared over 8 minus 4 squared over 8 plus twice 4 8 4x minus 7. Okay, so what we see here is we have 8 over 3 times 16 by 8 1 by 8 2 8 1 4 minus, we're left with 4 over 3. Why? Because 4 squared is 16, And here we have 8 minus 16 over 8 is 2 plus twice the square root of the integral from x equals to 4 to x equals to 8 of the square root of 4x minus 7. So 32, this and this is 32 minus 4 is going to be equal to 28 over 3 plus 6. So we have 28 over 3 plus 6 times twice the integral from x equals to 4, x equals to 8 of the square root of 4x minus 7. We can say let u be equal to 4x minus 7. That means that u squared is equals to 4x minus 7. Therefore, 2u du dx equals to 4, meaning that a half u du can be used to substitute for dx. When x equals to 4, u will be equal to 4 times 4, that's 9, it's 3. When x equals to 8, it is u is equals to 4 times 8, 32 minus 7 is 25, which is equals to 5. So this becomes 28 over 3 plus 6 plus twice integral from 3 to 5 of u times a half u, which is equals to 28 over 3 plus 6 plus the integral from 3 to 5 of u squared, which is 28 over 3 plus 6 plus u cubed over 3 to 5, which is 5 cubed, which is 125 over 3 minus 3 cubed is 27 over 3. So 125 minus 27 is 98, and so we have 28 over 3 plus 6 plus 98 over 3. 98 plus 28 is going to be equal to 126. So we have 126 over 3 6 by 1, 1, 4, 2, 42 plus 6, we have 48. So in other words, our long integral, I don't want to even write it up, is equals to 48. So on to problem number 19, and this is really interesting. So the integral from x equals to -1 to x equals to +1 of x to the power 2022 over 1 plus 3 to the power tangent to the power 2023 of x. So when you have this problem that kind of asks you to figure out the symmetry relationship about 0 of this function, and so all you'll need to do is split it into 2 from x equals -1 to 0 of x to the power 2022 of 1 plus 3 to the power tan to the power 2023 of x. That's from 0 to 1 of x to the power 2022 of 1 plus 3 to the power tangent to the power 2023 of x. Well, we will focus here and say let u be equal to -x such that du is equal to negative dx, and vice versa, obviously. And what that means is that we have, when x equals to -1, we have +1, we have 0, and since x is equals to -u, this becomes u, since this is an even power, so that remains. Then we have 1 plus 3 to the power negative tangent to the power 2023, that will propagate out. So we have, and then we have negative. So and this becomes, we can now flip the limits with this negative here. So we have u 2022 over 1 over 3 . And then when you multiply it up, it becomes 0 to 1 u 2022 3 to the power 2023 u over 3 to the power tangent 2023 to the power u plus 1. X to the power 2022 over 1 plus 3 to the power tangent 2023 of x. So what we've come to find out is that our problem is 0 to 1 x to the power 2022 times tangent to the power 2023 of x. We are converting back from u to x because we are not losing anything. So 1 plus 3 to the power tangent 2023 of x plus 0 to 1 x to the power 2022 over 1 plus to the power tangent to the power 2023 of x. Then we can bring those together. So we have x to the power 2022, and then we factorize, we have 1 plus tangent to the power 2023 of x over 1 plus, okay, 3 is there, sorry, 3 to the power tangent 2023 of x. And this would cancel, so we have 0 to 1, and now we're just integrating that, which is the same as 1 over 2023 x to the power 2023 0 to 1, and our answer is 1 over 2023. And so our bigger problem, negative 1 to 1, integrating x to the power 2022 over 1 plus 3 to the power tangent to the power 2023 of x. This is equal to 1 over 2023. This is the answer. Okay, so we move to the last problem. That's problem number 20. So lastly, problem number 20, which is the definite integral from x equals 0 to 2023 of the summation from k equals 0 to the floor function of x of the binomial coefficient of floor function of x, k. So what's the floor function? The floor function of x equals to k when x is less than k plus 1 but greater or equal to k. So in other words, it's that integer value less than the real number we're looking at. Okay, so what this is telling us is that, for example, the floor function of 2.1 is equals to 2. The floor function of 2 will be equal to 2. The floor function of 2.5 will be equal to 2. The floor function of 3 will be equal to 3, and so on and so on. So what this is telling us is that since our integration interval is 0 to 2023, that means from 0 to 1, the value of floor function of x is just going to be equal to what? It's going to be equal to 0. From 0 to rather from 1 to 2, floor function of x is going to be equal to 1. 2 to 3, floor function is going to be equal to 2. All the way up to 22 to 2022, 2023, the floor function of x is going to be equal to 2022. And so this guy becomes a constant at these intervals, right? And the interval is 1. In other words, what we are looking at is something interesting where we have the summation from n equals to this guy here, 0 to 2022, and we have k equals to 0 to n of n k, right? What it's just telling us is that we are summing in this interval. This guy just collapses to be a constant, and it becomes k equals to 0 to 0 of 0 k plus, in this interval here, we have k equals to 0 to 1 of k, and all the way up to k equals to 0 to 2022 k. So that's the scenario we do have, and it has led us to this point here. So this is our integration. Now, there's the important things for us to consider. So if we have x plus y to the power n, that's the same as n0 x to the power n plus n1 x to the power n minus 1 y all the way up to n, and we have n to the power n. Supposing x equals to 1 and y is equals to 1, so that we have 1 plus 1 n, that's the same as n0 plus n1 all the way up to nn. Okay, so 2 to the power n is going to be equal to in other words, 2 to the n is equals to the summation from k equals to 0 to okay, that is important. So that if we do have our problem that begins from n equals to 0 to 2022 of the summation from k equals to 0 of n of k, and it means we are just this is a geometric progression or series where the first value is going to be 2 to the 0, which is 1, and so we have 1 constant ratio 2 to the power n plus 1, which is 2023, minus 1 over constant ratio 2 minus 1. And so this denominator becomes 1, and so we have 2023 minus 1 as our answer. Therefore, the integral from 0 to 2023 of the summation from k equals to 0 to the floor function of x with the binomial coefficient of x k, this is equal to 2 to the power 23 minus 1, and that's our answer. So that brings us to the end of our solutions today. If you liked what you've seen, please don't hesitate to leave a like. If you haven't subscribed to our channel, we do really encourage you to consider subscribing to our channel. Here at Everyday Mathematics, what we do is we do enjoy solving these math problems and sharing with you their solutions. So until next time, bye-bye.